Excellent. 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 Friend of yours? No. Okay, oh, I have a book. Anybody need a book? Do you have your computers on? Okay, what we're starting today, welcome everybody to our first of several, our first of many lectures, lessons. I'm not quite sure I like to use the word lecture, you know? The word lecture has some negative connotations like
boringness. And that was your age.
many years ago. I was your age 45 years ago. 45 years ago I was in 7th grade, exactly. All right. So, yeah, lecture, that's like an old word, you know, that means like if you look up lecture in the dictionary, it just has one word definition. It says boring, okay? But it's not really a lecture, because don't I ask questions and have you answer them and kind of like, you know, have a little fun, you know? I don't think you're allowed to. I think if you have fun in a lecture, I think the police knock on the door. Yes, who's there? It's the lecture police. No having fun in lectures. Okay. Now, so what we're going to do is we're going to skip around a little bit. So what I want to kind of get over, and we're going to kind of discover it, we're going to do a lot of labs, is that the concept of motion and forces, right? Because why? Well, what was the unit we just finished? Was motion. Okay. Well, if something's in motion, something put it in motion, correct? And what put it in motion? Forces. So there's a connection, isn't there, between forces and motion? Yes? So, this is what I propose. I propose that we don't pretend that everything is not in motion, and we are discovering forces from the very beginning. We're from another planet where they don't have forces, and we're coming to Earth where they do have forces, and we're learning about forces for the first time ever, right? Yes? Was everybody on Earth yesterday for a few years? Is anybody totally new to Earth? Was everybody born here? Any aliens? No, well, I know. I know, exactly. But everybody's from Earth, so you know what forces are. Anybody watch soccer? Like, how does that ball travel? You kick it, right?
You kick it.
All right, okay, all right. Soccer, I know. Football. I say soccer. You say football. When you say football, I think of something completely different. I think of a bunch of like Vikings, like playing on a football field and banging each other in the head. When I think of football, when you think of football, it's something quite different. Okay, so how did that ball get in the air in football? You kicked it, right? Right. So you know what forces are. So I want to start by finding a connection between forces and motion. And this is what I'm going to propose. I'm going to say that we've done motion now, right? And now now you've graduated from motion school, okay? You have your diploma, and you are now going to be rewarded with the 3 laws. You are now the Jedis of motion. And now the Jedis of motion have to take the oath of office. And we're going to take the oath of office by repeating the laws that govern motion. Did you know that? I'm not being silly. But the Jedi thing, yeah, all right, fine. But do you know that there are laws that govern motion? There are 3 laws that govern all motion. And we're going to pretend we're Jedis, and then you are the Jedis of motion, and you're going to repeat these laws after me. Correct? Yeah. You ready? Okay, let's do the first one. Okay? You're going to want to write this down. Even though it's on the film, you don't really have to write it down. You may want to just sketch words, like write words down, right? The first one is called inertia. Okay, now when we do inertia, let me see if I'm on screen here and how I'm on screen. All right, good. Let's just move it over this way, just a pinch. Okay, good. Okay, so this is what you're going to do. You're going to repeat after me, okay? If you're really going to become the Jedis of motion, you have to take the oath of office. And the oath of office is the following. Are you ready? Repeat after me. Okay? Right. Are you ready? Okay, what do I begin with? Has anybody ever heard of inertia? You've heard of inertia. Does anybody know what it is? Yeah, what is it?
It's where if you're going in a car and the car is moving left, your body moves left with it unless something stops your body.
Excellent. So you kind of know what it is, right? Yeah. So you're not an alien? You're not. Well, you may be an alien because you may have this on your alien world, but you probably are not an alien because you know what motion. So you've lived on Earth a while. Excellent. Okay. So may I put that in more disciplined terms? I don't mean that in a negative thing. I'm just gonna. All right. So we're gonna take the oath of office. Yeah. Okay. Yeah. You ready? Okay. Good. An object. Say it. An object in motion. Will remain. Let me see if it's on. Who's on the board? I got a little room. Will remain in motion and an object at rest will remain at rest unless the object is acted upon by an external force.
I think you have to move the board up.
I gotta move the board up? Okay. No, it's on there, but we will move the board up. That's not a problem. How's that? Is that good?
Yeah.
Can you see that well?
Yeah.
Shall we move in a little bit? We're going to zoom in on the Jedi oath of office. Okay. Here we go. Cool? Okay, excellent. So now you guys are 1/3 of the way there. When you go home, you can tell your parents that you all need a bigger bedroom, because you are now Jedis of motion, okay? So you can ask them if you can have your own house. Let me know how that goes over, okay? Okay, all right. Second law. You ready? F equals MA. That's the title of the second law. Are you ready? Yes? F equals MA. I'm going to tell, yes, I was going to say, well done, B. I was going to say exactly what F, M, and A are. So I'll do that. So B is already telling us. So I better get to work, or she may tell you before I tell you. F is force. M is mass.
Accelerate.
And A is acceleration. Right? Can you see it? Is it down below? Oh, you can't see it. Okay, so we'll move it up. Can you see it now? Can you see it now? Yes or no?
You can't see the first law.
That's okay, because we're working on the second law anyway. Okay, I'll move it down a little bit. Tell me when you can't see it. Up there. Can you see it?
Yeah.
Can you see it?
Yeah.
Can you see it?
No.
No? Can you see it?
Yeah.
Okay. Yeah. So, are you ready?
Yeah.
You ready? You ready?
Yeah.
If, I'm just going to go down here, and you know what that is, right? Okay.
Yeah.
If a force, wait a minute, I can spell, I put if a fos, okay? All right, I know. I'm getting this feeling, okay? I'm getting this feeling that there's something wrong here. There's a force telling me that I misspelled force. Okay? If a force is applied to an object, what do I call that object? That object has a name. Matt. Very good. But it's Mass. But to you, who's not yet a Jedi, it's Mr. Mass. Yes, thank you. So you say, you always refer to the M as Mr. Mass, unless you're a Jedi, okay? Mr. Mass, okay? But I can say Mass. You can't, okay. Okay, so you can say object, though. You can say object. Okay, now, if a force is applied to an object, that object, okay, that object will accelerate while I know your parents are watching this and thinking, boy, your teacher really can't spell, can he? I know, terrible. Okay, I can spell, really, Mom and Dad, I can spell.
This is why you're not an English teacher.
Yeah, but I'm not teaching science in Sesotho, right? Okay, accelerate while the force is being applied. Okay, are you with me? You sure? Yeah. I spell applied, right? You're making me paranoid. Okay. Now, Jedi Masters can be paranoid. Okay, so now, let's do this. Let's move this card over here. No, it's too bumpy. Okay, we're gonna move over here. We're gonna do number 3. Okay, are you ready? Yeah. All right. We're gonna do number 3. The third law. You guys are almost finished. The third law is action. Who said that? Who said that? Who said that? Abdullah? Did you say that? Yeah. Do you want detention? Yeah. You do? I wasn't going to give you detention. I just asked you if you wanted detention. But I was excellent. Excellent. Superior. Excellent. That's right. Action, reaction. Okay? Yes, are you ready? We'll put this into words. Yeah. Is that okay? Are you ready? Okay. When an object applies a force.
You said applies.
A what?
You said applies instead of applies.
When an object applies applies a force. A force, put in parentheses, a force, action to another object. Okay? The other object will apply an equal and opposite force back. I know, I'm a little dyslexic, I apologize, but it's really hard. It's really hard to write on the board. A force, what did I say? Back, okay. Did I really?
Yeah.
Okay. I'm a terrible speller because I like exchange words like back to me is like this. That makes more sense than that sometimes, yeah.
What?
Yeah, I don't see words like you guys do. Okay, back. Okay? Equal and opposite force back. Is that right? Did I put that right?
Yeah.
Okay, good. All right? All right, now, we're going to read them together. We're going to actually take our oath. You got to raise your right hand. Okay, now you got to raise your left hand because that might be people might be offended if you raise your right hand, so you gotta raise your left hand. Left hand is pretend both, okay? So let's read them together, okay? All right, let's move it over here. Shall we move this back so we can see the whole board? Okay? All right, are you ready? Okay, you're taking the Jedi oath of office, the motion Jedi. Okay, number 1. Okay, you ready? You ready? Okay. 1. Inertia.
Inertia.
An object in motion will remain in motion.
An object in motion will remain in motion.
And an object at rest will remain at rest.
And an object at rest will remain at rest.
Unless the object is acted upon by an external force.
Unless the object acts upon by an external force.
Excellent. Number 2. F equals ma.
F equals ma.
If a force is applied to an object mass,
If a force is applied to an object mass,
that object will accelerate
that object will accelerate
while the force is being applied.
while the force is being applied.
Give me a yeah!
Yeah!
Okay. Number 3. We're almost over. Action, reaction.
Action, reaction.
When an object applies a force action
When an object applies the force action
to another object,
to another object,
the other object will apply
the other object will apply
an equal and opposite force back.
an equal and opposite force back.
Congratulations! Yeah! I have a class of motion Jedis. Yeah! All right, excellent. Okay, good. Now, I'll look into that. Okay, there's been a delivery problem. Okay,
Target.
yeah, because I get them from I order them. I order the lightsabers from a galaxy far, far away. So they don't do FedEx. Okay. All right. So now, let's talk about it and see if you have the right training to be a Jedi. This is going to be a training test. Now you're Jedi, so I'm going to put you in the field, okay? And I'm going to see. We're going to go, to advanced training, okay? You're going to go to advanced training school. Yes, I'm done. I can't hear.
Yes, you have a video reaction.
I do. That's right.
Yes.
You mean from last year?
Yeah.
I do. I do.
Action reaction 2.0. Action reaction. Come Terminator Force. Oh my. Mr. Raggy. Iron Chad.
All right, now, have you ever seen an object just resting on a table like this?
Yeah.
Okay?
Yes.
Now, true or false? That object, I'm going to stand right here for the next 1,000 years,
Wow.
and is that object going to move?
Maybe.
If a force doesn't act upon it, is it going to move?
No.
Okay, are you ready? You tell me if a force is applied to that. Okay? Now remember, you're Jedis and you're going to be able to see this. The camera may not pick it up, but you'll be able to see it. Okay?
Yeah.
Are you ready?
Yeah.
Tell me, and we'll wait, and to see if an object's applied. You ready?
Yes.
Yeah.
Yes! Did you see that?
Yeah.
I wonder if the camera picked that up.
Yes.
Right? Have you ever seen that?
Yeah.
Have you ever seen an object that was at rest all of a sudden move?
Yes.
Yes. Pump it.
Is it magic?
No.
No, it makes sense, right?
Force.
Push your book across your table right now, just a little bit, just like 3 or 4 inches. Just push it. Now that is moving, right? Because you pushed it. Okay, now according to that rule, now that rule sounds easy, doesn't it? Sounds easy, almost kind of silly, right? Well, the problem is this. This is the problem. The problem is this. If that's true, the reverse has to be true. Let's see if it's true. Okay? I am in the food store because you said you went to Abella's or Lulu's or whatever, and you went and you pushed the cart down the aisle, right?
Yeah.
And the cart's kind of easy to push, isn't it? I mean, don't you want to just push it really fast and kind of like play with it, right? And your parents say, no, you can't do that. Okay, no, don't do that. Yeah, you're gonna hurt somebody, all right? So your parents like get all kind of cranky and say, no, you gotta stay here, right? Okay. Yes, Derek.
They have these new carts that you can, at the bottom, there's this bar you can put down and you can stand on it.
So they have carts that have a ramp on them somehow, and you can like, do wheelies and push other people or take your grandfather shopping or what?
Have you ever gone to HEB?
Where?
HEB?
HEB?
Yeah.
Is that on your planet or is that on Earth or is that in Abu Dhabi? I've never heard of it.
US.
It's in the U.S. Where are you from?
Texas.
Where?
Texas.
Texas. Is that like a Texas thing? I never heard of it. What did you say? HEB? No, I never heard of it. Cool though. Cool carts. Okay, so the carts are kind of fun, but listen to this. If the cart has things in it, and you're pushing on the cart, right? Right? Doesn't it take a little force to get the cart moving, right? Doesn't it? So you have to apply a force to get it moving, right? This is a constant velocity, right? Correct? Yes? So I'm going to apply a force, and it's going to accelerate right here. This part is acceleration, right? And then this part here is velocity, right? So you're going to apply a force to here, and it's going to accelerate, all right? And then it's going to go to constant velocity, right? Yeah? Yes? Here's Chowdy going down the aisle. And isn't it, if the wheels are good, you can literally push that down the aisle with one finger, right? What force, are you applying a force? Yeah, you're applying a force. What force are you applying? Yes?
A push.
A push, but what amount of force are you applying?
A lot. A little.
If you're applying a lot, wouldn't you be accelerating?
Yeah.
But you're not accelerating, are you?
Oh, so
You're going at a constant velocity. But if you stop pushing, what's going to happen?
stop.
The cart's going to decelerate and stop, right? Yeah. So it's going to decelerate, meaning a force is being applied if it decelerates, right? Because what's deceleration? It's just negative acceleration, right? So this is plus acceleration, accelerates, and this here is negative acceleration, and it's going to stop. Right? But what's the force? This force is push. What's the force that's decelerating it? It starts with an F. Friction. Yeah. Friction. That's how you represent friction. F sub F. That's friction. So friction is a force, isn't it? So listen to this. Tell me if you understand this. You ready? Okay. What have we learned today? Okay, let's see. Let's see if we can do this. Okay. You ready? Jedi? Okay. What's plural for Jedi? Jedi. Okay, good. Okay. Now, I have a cart at rest. And according to the first law, that cart will stay at rest, correct? Unless I apply a force to it to make it move. Okay. I apply a force, and that force accelerates. Right? So, rule 1. An object at rest will stay at rest unless acted upon by an external force, right? Okay. Right? Okay. I apply an external force. Rule 1. I accelerate. F equals ma. Rule 2. Right? Okay? Right? That cart is going at a constant velocity, isn't it? Right? Isn't it? Okay. But if I let the cart go, it'll stop. So what force am I applying? The force that is equal and opposite to F? Friction. Equal and opposite. I push against the floor. No, the cart. The cart pushes against the floor, right? The floor pushes against the cart, right? Newton's third law. Right? Yeah? Yeah? So, the friction and my force cancel. So is the force that I'm applying, does that keep the cart in motion? The cart is in motion because of Newton's first law. It's going to be it's going to be in motion forever. The only force that am I applying a force? Am I applying a force because I want it to be at that speed? No. I'm only applying a force to overcome what? The force friction. Now the force friction, here's the friction, here's my force, they cancel. Is the cart moving? Yeah, it's moving. Isn't it still moving?
Yeah.
What? There it goes. There's Chatty. Do. Watch him. Yeah, he's moving at a constant speed, right? So my force is being canceled by the friction, isn't it? Right? Isn't it? Isn't it? Yes? 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 Okay? Right? So is the cart moving?
Yeah.
Well, how is the cart moving? How? Yes?
Because the force you're applying to the cart is more than the force of
No, it's not. The force that I'm applying is equal to the friction. So my force is canceled by the friction. So why is the cart moving? Why? It's very easy. Why is the cart still moving? Because of what law? Because of what law? No, it's not accelerating. No, not action reaction. The action canceled out with the reaction. No! The action and reaction happened, but my force was canceled, gone, canceled, right? Canceled. My force was canceled. So is there a net force on that cart? What's the net force on the cart? Zero, right? Neutral, right? So why is the cart moving? Why? Yes! 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 Because of inertia. Do you get it? The cart is moving because of inertia. Do you understand? We applied all three laws. Look, guys, this is big. This is complex. This is really hard. Do you follow it, though? Why do you follow it? Because you are Jedis. Yes? All right, let's go through it again. Okay. You ready? Okay. You ready? Okay. The cart's at rest. Rule number 1. Okay. I apply a force to the cart and it accelerates. Rule number 2. Yes? I stop applying a force to the cart because it's going at a constant velocity. Right? Rule number 1. Right? You ready? Yes? Let's expand this. Okay. I push on the cart pushes on me, right? To get it going, right? Right? Okay. Newton's third law. Action, reaction, right? The cart pushes on the floor pushes back. Friction and my applied force, right? Right? Okay, good. What rule is that? Action, reaction. My force, my applied force, is canceled by the frictional force, right? Yes or no?
Yeah.
Rule number 3, right? No, rule number 2 is the force that I applied to get it accelerated. Rule number 2 is also what? The force that I'm applying that's overcome by friction, rule number 3, right? Now, my force is canceled by the friction and vice versa, right? Action, reaction, right? But this is the key. This is it. You ready? You ready? But the cart's still moving. How is it still moving? What rule? Rule 1, inertia. Excellent. End of video. What do you think?
Amazing.
Yeah, cool or what? I mean, wasn't that cool?
Yeah.
Do you know what I just did? Do you know and you didn't even see it? You didn't even say it because you're Jedi. I just did the entire chapter.
What?
I just did the entire chapter.
I'm scared.
Isn't that scary?
Yes.
We're going to pick it apart. I'm not finished. I just did, what did I say we're finished? No, I just said I did the entire chapter. Today's lesson was a complete overview of everything. Because what did I want to do? I wanted to connect what we did in motion with forces. But in doing so, what did I do? I covered everything.
Wow.
Wasn't that cool?
Yeah.
Yeah, I did the whole entire chapter. If you read through the chapter, everything I just taught is in that chapter.
Yep.
Yes? You get it? Are you doing it? Are you looking?
Yeah.
You see it? Isn't that really cool? Now, who's your best teacher? Sorry.
Mr. George.
All right, there we go. Okay, end of video, part 1. Forces and motion unite. Cool? Cool?
Yes.
All right, bye.
You didn't follow. Slowly. Turn